Okay, we are starting. Let me start the tape recorder too. This is Math 120, fourth session, January 31st. I hope everybody is doing great. So let me just adjust this window and make sure everything. Wanted to be able to see both the PowerPoint and the screen and the camera, what is actually being recorded. Okay, it says I cannot minimize when I'm recording. Oh, too bad. I guess we have to go like this. Well, good evening, everybody. I'm glad to be in the class again. I hope you are all doing fine. Let's start with prayer. Father God, we thank you for another session, another opportunity to learn and sharpen our skill, sharpen our mind to be used for your ministry. Thank you for this whole science of math, even though it may not be fun while we are going through it, but if we apply ourselves and work hard, we will reap the benefit later on. And I believe one of the greatest benefits is being able to think critically and analytically. Father, thank you for the mathematical pattern that you have put in this whole universe that we can study. Bless all the students in class and online for this course and all the other courses that they have. May your name be glorified. May we be able to serve and honor you more and more and love you more and more. In Jesus' mighty name we pray. Amen. Hello. Good to have you. All right. This session we will go to fraction, percentage, and ratio and conversion from metric to British system and vice versa. But before we go there, any questions you guys have? No? Everybody is okay? Great. Okay, let's continue. Fractions, as you know, for the online student, please follow with the PowerPoint, except for the places that I go to the Blackboard. But please follow with the PowerPoint right now. You know, fractions, what we talked about, you know, whole is the whole thing, 1/1, halves, 1/2, third, 1/3, fourth, 1/4, and I've tried to diagram and visualize that for you in that PowerPoint. You can have rows, slides. You know, the fractions are used in many, many ways for presentation of graphs, for learning, for constructions, all kind of stuff. Let's start with percent. What is a percent? Percent is simply a ratio of some number to 100, a part or fraction. Expressing number as a part of 100. We divide the numerator by denominator and multiply by 100 and add the percentage sign. As you can see in your PowerPoint, fraction to decimal, you know, if you have a fraction to decimal to percentage, we move the decimal point to a place to the right and attach the percentage sign. Basically, if you have a decimal, you want to convert it to percentage, you multiply by 100. That's all. Let's look at examples 1 and 2 on page 444 and 445. And then example 3 on page 445. I already saved time. I wrote it on the board. Let me put my glasses on. Okay. Example 1 talks about 5/8 as a percentage. So we divide it, you know, like this is a sign of division. 5 divided by 8 is 0.625. To convert that from decimal to percentage, you just multiply by 100. So the decimal point moves this way, you know, it comes to this place, so it's 6.25 is the percentage sum. Okay? So what it means is, or can you tell me, what does this mean? 6.25%. What does this mean when we look at 5 and 8?
It is 6 and 2,500 of an object or something.
That basically means 5 is 6.25% of number 8. Or, you know, if you think of it, I want to draw it. Let's say if this is 8, this is half. 5 is this much of 8. Okay. 62.5. Right. Following. Or if you have a number, 0.47, if you want to write it as a percentage, all you have to do is multiply by 100, so that this decimal moves 1 and then 2, so it comes here, so you won't write it, so it's 47%. Okay? Now, you tell me 19%. How can I write that? Let me see, that's example. This is example number 3. If I want to write it as a decimal, how would you write 19%? Yeah, so it's basically 19 divided by 100, which is the same as 0.1912. So you move 1, 2, and that's 180. So it would be 180 over 100. Okay? Which is 1.80. If I want to write in decimal form. Right? Any question?
So is it that the larger the number gets, let's say it's 1,180.
It's what?
1,180. Can you do 1,180?
Okay. What are you trying to find out?
Because I'm trying to see, I think that as the number goes larger, like the 19% versus the 180, that you actually move the decimal over.
Yeah, because you're dividing by 100. If you have whatever number, let's say you have 1,000%. Yeah. So you have 1,000 divided by 100. This will be that will be that. So you get 10. After 10, because it's 10 times larger than 100. This, for example, when we say 180%, again, it's larger than 100. That's why we get 1.8. Later on, this will be used for example, to say what's 19% of whatever number, x. In order to find what's 19% of x, you just multiply that by x. If you have, let's say, if you have $1,000, what would be 20% of that?
800?
No. What number? 20% means you take 1,000 multiplied by 20%. So 200.
Yeah. So it's calculation.
Yeah, 200. Or you can think of it fast in your mind. if it becomes 100%, it will be equal that number. So I would think, what number, uh, uh, if I have 20%, if I multiply by 5, I get 100%. So how much dollar, if I multiply it by 5, becomes $1,000? All right. Okay. Good. Then let's look at. In other words, they have example 2 also. If we have in the other way around, if you have 0.47, example 2, if you want to write it as a percentage, how would I convert that to percentage?
Is that
Sorry,
times 100?
Yeah, exactly. Multiplied by 100, which is what?
4.7.
No, you have 2 zeros. So this moves this way, so you get 47%. Following me? All right. Say, let's move to talks about example number 3, page 445. We did that already. Okay. So that's how you change from decimal to percentage. You just multiply it by 100. If I had 3.7, if I wanted to write it as a percentage, what would I do? What would the answer? Multiply by 100, which is what? Which is more than. Yeah. Yep, 307%. Well, if I put a percentage here, that is equal to that. Because 370 divided by 100 is equal to 3.7. Okay. Following me? Now, some of the practical things about percentages, especially for figuring out taxes, discount, and all that. If you go to page 446 of your textbook, basically, when you want to find the amount of the tax that you pay when you buy an item, you multiply the tax rate, depending whatever the tax rate is, by the cost of an item. So let's say the cost of an item is $894, okay? And tax rate is 7.5%. How would you figure that out? Well, first convert that.
The whole percent.
Yeah, 7.5 means 7.5% means 7.5 divided by 100. True? Okay. So I move this. Yeah, I have 2 0. So I have to move here to. I have 0.12 to 0.075. Right? Okay. You agree? Yeah. Then, okay. Then multiply by 894. Which the answer is 67.05. Do what? Do that. Which one? The tax. Yeah. So you get the tax rate, 7.5%, whatever percentage is tax rate, multiplied by the price of the item, but then you get this much tax you pay. So the total amount of the money you pay would be cost of the item plus the tax. You pay taxes.
Right, so, okay.
Mhm.
I know I'm wrong.
No,
So
that's
894, yeah, 8% tax. Could you not just do the 894 times 8, or do we have to break that to the decimal?
No, if it's 8%, okay. If it's 8%, well, right. 8% is 8 over 100, which is the same as 0.08. Then you have to multiply,
And then, okay.
which would be different than this number. Okay. Then the total price that you pay would be the tax plus the cost of that. You can. This is how you can figure out discount amount. For example, I think there was a on example number 5 on page 446, 447. It says a computer with an original price of $1,460 is on sale for 15% off. What's the discount amount and what's the computer sale price? So first, the discount amount is whatever is the discount rate times the original price. So here we have it's 15%. That's the rate. The price is $1,460. Okay, so 15% is like 15 over 100. You don't need to do that. I just do that to make it easier to visualize it. You can just go 1 and 2 because they're 2 zeros, and this is same as 0.15 times 1460. Okay? Then your answer would be 219. So that's the discount price. Okay? So how much actually the computer costs? You take the original and subtract it from 1460 minus 290. Okay? And the answer is 1241. That's how much you pay. In other words, looking at it another way, 1241 divided by, I'm sorry, 219 divided by 1460 would be 15%. So the discount, so when they say 15% of the original price, it's about 6.5. It just goes. You want a number that if you multiply it by that number, you get this price, which is about 6.57. Okay, you following me? You know what I'm saying? So this is your how much discount.
So would it be fair to say that that would be 1/6 of the original price?
Yeah, about approximately. Just the discount. Okay. So we talked about that, and actually we did that. Sale tax amount is tax rate times item cost, percent and sale prices. We did that. Did we do? Yeah. Price increase. Let's say a couch. Please now look at your PowerPoint. A couch sales price is $400. Is going back up to $450 on Friday. How much will I save if I buy it before Friday? So what percentage saving will that be? So I take the current value minus the starting value, divide. So, okay, let's go. It's 450. I knew this. Almost. Yeah. Actually, I'm going to put this over here. Makes it easier. So, the price is 400, it's going up to 450. How much will I save if I buy it before Friday? 450 minus 400. $50. Okay? What percentage saving that be? So you want to know how much you're saving. So you take 50 divided by the original price. And that is 1/8 or 0.125. How much, if I want to write it as a percentage, how much that would be? What would be that?
Is it 0.25?
Yeah, because I take 0.125 times 100, I get 1.5. I'm sorry, let me just double check that this Zoom is recording. Yeah, recording. Because you know, last week we had lots of trouble. All right. So it would be 1.25%. I'm saying. All right. Let's continue. You can present percentage by a pie chart, as you can see on your PowerPoint. These are great. We do that at the school, at the church. This is something you can do with your budget, with your finances, in order to make sure you don't go under debt. You know, like let's say if these are the we want to present the age of people. If the gray area is under 21, 15% are under 21, 20% are between 22 till 30, 32% between 31 to 40, between people between 41 and 50 constitute 28%, and 51 up only 5%. So the largest group of people are the people between age 31 to 40. And you know, this is can be used for many functions, many purposes. Clear? You can use percentage in a daily life when you want to figure out sale and percentage of. This is just for yourself to review, but I want to look at it. Example 6 on page 448. We have here is a we also have a simple tax and computational tax system, that compound tax system that keeps adding up. Like, of course, this is old. The whole tax system has been changed so much, but figuring out your taxes depending if you're single, whether you're married and file separately, married filing jointly, head of a household. You can see all the different amount of tax rate for the amount of money that you make. Basically, if you look at example 6, when we pay our taxes in a couple of months, you basically take your gross income, whatever money you make, and subtract it from all the different adjustments that you make because of the size of your family, your income, and all that. Let me see. No. And then you subtract that from your gross income, you get your adjusted gross income, and then based on that, you again subtract exemption deductions. Then you take a look at the tax rate, tax table, and you find out how much taxes you have to pay. Of course, it's not that simple, the whole tax system. All right? Any question? All right. Percentage and changes. When we want, for example, find a fraction for percentage increase or the percentage decrease. Amount of increase divided by the original amount of the decrease divided by original amount give you the percentage of increase or decrease. You find the percent increase or the percent decrease by expressing the fraction in step 1 as a percentage. Let's look at examples 7 and 8 on page 450 and 451. Examples 7 and 8. Okay. Example 7 says, in 2000, the year 2000 world population was approximately 6 billion. And there's that figure 8.2 from United Nations. Then that figure shows the world population in year 2150. Then they have 3 different projections: high projection, medium projection, and low projection. Ask you the question: find the percent increase in the world population from the 2000 to 2150 using the high projection data. Yes. All right, how would you do that? I want you guys to tell me. We want to find percent increase in the world population from the year 2000 to 2150 using the high projection data. The high projection data, if you look at your textbook, is that blue curve. What does it say would be the world population in the year 2150? Very good. Okay, that's the projected population. And what's the population in the year 2000? 6 billion. So you get the projected population minus 6, okay? And you divide that by the original population, which was 6. So this becomes 24 over 6, which is 4. So what does that, if I want to show that as percentage, what would I do? So this is the population of the world in the year 2150. This is the population in the year 2000. We want to know the percentage increase You take the projected one minus the current one, divided by the current one. Okay? You got 4 billion. Or no, just 4, not 4 billion, I'm sorry. What percentage increase are you talking about? How do I convert 4 to percent? Take 4, what do I do? Divide by 100. Multiply by 100. So, I get 400%. What does that mean? Put it in plain English. In the year 2150, the world population will increase by 400%. Almost 4 times. And it makes sense, which is more than 5 times.
So, on your example, there's 30 minus 6. Okay, but in your PowerPoint, the amount of increase divided by the original amount, just right there on the PowerPoint that you currently have.
Okay, amount of the increase. So I want the amount. I have to find the amount of increase. 24.
Oh, so that's the that's the amount.
I take how much it will be and how much. What's the population right now? Subtract them. I get the amount increased divided by the origin.
I see that.
Okay. And then another example says find the percentage decrease in the world population from 2000 to 2150. In 2000, the population is 6 billion. Decrease, the only thing that we can see in that graph is a low projection that tells us would be 4 billion. 2 billion people would die. So you take, again, you find the percentage decrease divided by the original, which is 6. 6 minus 4 is 2. 2 over 6 is 1/3. If you want to show it as a decimal, 1/3 is 0.33, and if this keeps going on, you can just write it as like that. So it would be, if I multiply this by 100, it would be 33 1/3%. Follow? All right. Page 451. Finding percentage decrease. A jacket. I want you guys to tell me what to do, okay? This is a jacket price currently is $135. All right. The sale price is $60.75. So it's going to go down to $60.25. Find the percentage decrease of the sale price. What would I do?
Would you start with 135 minus 60, 25?
135 minus 60.25, and then?
And then what you're going to do is you're going to get your difference, which is the amount of the decrease.
Okay, and then?
Divided by the original, which is 135.
Yeah. That's it. So you do the subtraction and division, and the answer would be 0.55. Which, if I multiply by, if I want to find the percentage, what do I do? 100, you get 55%. So the price is going to be decreased by a little bit more than that. Sure. But it's also recorded, hopefully.
When I'm sitting down and doing stuff,
Sure.
I get that it's recorded.
Sure. All right. When we want to find the interest, basically you've multiplied, this is a rule, the principal amount times the rate times time. So simple interest, not a compound, but a simple interest. So if you are talking about simple interest, you take the principal amount, let's say you're putting money in a saving account, multiplied by the rate, multiplied by the time, gives you an interest. That's a rule that we need to know. It says look at example 1 and 2, page 455 and 456. It says example 1. Let's say you put $2,000 in your saving account. The rate is 6%. You want to know how much you will have money after 1 year. So you put $2,000. Okay. The rate is 6%. The time is 1 year, right? So you get 2,000. 6%, I can write it as 6 over 100, yes? Times 1. This 20 will go with that. So you have 20 times 6 times 1, which is 120. So you will get $120 interest after a year. All right? Any question?
What you just did there with the zeros, does that go along with like cancel?
Right.
Like
You had $1,000,
right.
2,000 times 6%. Okay?
Right.
Same as 2,000 times. I can write 6%. If I want to write that's decimal, it would be 6. I'm dividing by 100. So it would be 1, 2, this. Okay? Or simpler than that. 6% is what? 6 divided by 100. True? So you have, since this is 1, if this one, let me show you, I do it in 2 also. Since this is 100, 100 goes to 2,000 20 times. Yes? So you get 120. Let's say this was, instead of 100, it was 150. Okay? Then, how would I do that? 150, I can write 150 as 15 times 10, right? Now I can take 2,000, 10 goes to 2,000 how many times? 200. So it becomes 200. So I have 200 times 6, 1,200 divided by 15 in the division. This is, simplifying when you multiply fractions. Because 2,000 is just like 2,000 over 1. Follow me through?
So it had nothing to do with like cancellation of 0, 0, or 0, 0.
You can do that too. You can do that too if I have 50,000 and if I have provided this multiplication, I have 5750. Okay, let's say 5,700. Okay. Simple thing you can do, because this number is the same as 57 times 100. 100 goes into 57 500 times, or just multiply 1, 2, 1, 2 cross that, because it's 100.
That's what I was asking.
All right?
Yes.
All right. Example 2. Example 2. Student took out a simple interest loan of $1,800. All right. So took a loan of $1,800. For 2 years at the rate of 8%. How much interest he has to pay at the end of the 2 years? So we have 800. What's the rate? 8%. What's the T? 2. So you have 800 times 8 over 100 times 2. How can I simplify these? 800 goes to 100.
8 times 8.
8. So it's 8 times 8 times 2. 8 times 8, 64. 128. So this is the amount of interest we will pay, yes? No, I'm sorry. 288. 2. No, oh, I'm sorry.
It's 18.
I missed it. This is 18. Yeah. Yeah. Okay. Sorry. So we have 18 divided by 100, which is 18 times 8 times 2 is 288. Okay?
Yes.
This helps you to figure out, when you take a loan, how much interest you're going to pay. Some of these credit cards, when they sound crazy interest rate, 20%, you've got to watch out for that. Example 4, 5, 6. Example 2. Oh, okay. Now, if the year was, let's say instead of 2 years, if the loan was for 6 months, what would be my T?
No. It would be 12 is usually months. 6, 2, 5. Yeah.
Why are we looking at it?
If instead of 2 years, the loan was for 6 months, yes, or 1/2. So it would be 1/2. Okay, just have to keep that in mind. Okay. Future value of a loan. So you take the interest, add it to the principal, So a future value is A, actually, here. As you can see, future value, if you call it A, you have a principal, then you have the interest, and the interest was principal times the rate times time. Or we factor P out, so it's P 1 plus RT. Follow?
Feature.
Yeah.
The principal.
So let's look at, for example, examples 3 to 5 on page 456, 457. It says a loan for 1060 has been made at a rate of 6.5% for 3 months. So let's first always, whenever you want to do math problem, always first write the things that you know. How much is the loan? How much is the loan?
Number 3.
Yeah.
Loan's $1,060.
1,060. What's the rate?
Rate is 6.5%.
6.5%. And for how long?
For 3 months.
3 months. So first, always write the things that you have. Okay? If you want to find how much this loan will be after 3 months, you want to find the future value. So A would be principal, which is 1060, parenthesis, 1 plus rate is 6.5%. Now, tell me, how much, what's the time? Time. The time is 3 months.
Oh.
Or, to make it easier, yeah, 1/4. Okay? So, we will have the future value as 1060, 1 plus 6.5%. In order to, it means 6.5 divided by 100 times 1.4. And basically you do the multiplication and addition and all that. We start from here and we do all the multiplication and all that. We find the final value, which is 1077.23. So, in 3 months, in just 3 months, how much that loan is increased? If I just say 1077 from 360, $17 in 3 months. Now think of it, if it's only 6.5%, think of it. Some of these credit card charges plus 20%.
Yeah.
And if it's not, for a longer period of time, think how much you have to pay extra. So avoid using credit card as much as you can. Now, also, this can be another way. Look at example number 4. Now, you tell me, in example number 4, what's the loan amount? You borrow 2,500 and promise to pay back 2,655. So you borrow 2,500. So we have the original, or actually the T. 2,500. How much you promise to give back? 2655. So that means this is the future value. In how long? 6 months. This should be, if I want to write it in years, 1.5 or 0.5. We want to find the rate. All right? So you just plug in this information into that equation. A is 2655. P is 2500 times 1 plus R times 1/2. Okay? So what you do here, you take, as actually already multiply that by the parentheses, so you get 2500 plus 2500 times R times 1/2 equal to 2655. Yes?
Let's see, okay, so I just want to make sure I'm reading that right. At the very top line, we have 25, first parentheses, I'm sorry, put down 3.
Here?
One more, there you go. So it's 2500, and then first parentheses, 1 plus R times 1/2, right?
Yeah.
So we have to put the R times 1/2.
Yeah, because
Okay.
T is 6 months.
All right.
Okay? So I multiply this 2500 by R by that. This is, if I want to, I can subtract 2500 from both sides. This cancels 2500. I get 5, 5, 1, 155 is equal to 2500 times 1 divided by 2. 2500 divided by 2. It goes to, it's actually would be 1, 2, 50. Following me? For sure.
Yeah, it's just you have to do it.
All right.
So it's 1.250.
1,250 times R. So if I want to solve this for R, I divide both sides by 1250. This cancel, you do this division, end up having 0.124. Or if I want to write this as percentage, it would be what? Multiplied by 100, 1.24%. So he's paying he's having a good deal. 1.25%. Yeah, 1.24% is a very low interest rate. Now we have compound interest for installment loans, minimum payment, traps, mortgage loan. This is again for your personal review, but let's look at that on page 460, 490. Look at that table on page 460, table 8.2. Year number 1, the first year, starting balance is 1,000. So the future amount, when you plug it into that formula, would be 1050. So you have $50 interest added, okay? Year number 2, it starts with 1050, okay? And then you have 1050 times 1 plus 0.1, you end up 1102.50. Again, you can, or you can, if you take a, we can factor things up, it would be 1 plus 0.05 times 1 plus 0.05, or 1 plus 0.05 to power of 2. In other words, if you keep going on like this, basically the rate, the formula for compound interest rate, which home mortgages are like that, it's A, P, 1 plus R to power of T.
Yeah.
See that? That's for compound interest. So let's say most home mortgage loans are 30 years. T becomes 30. Think about how much you're paying.
So this usually we have to figure out how to not take your minimum payment on this calculation, right?
Yes.
Interest.
Yeah, that's why they say, for example, if you can pay 1 month extra every year, you will save a lot in the long run. Just 1 month extra. And for that, the key is this. Take your monthly payment divided by 12, because none of us have enough money to make a 2 payment in a month. But if you divide that by 12, it's doable.
Just a little bit.
Yeah. But you will save a lot in the long run. Yeah. Measurement. Okay. Now we go to whole another feature. We have metric system, and we have also King Henry system, the British system. Most in the world they use metric, but in America, England, I think Canada, Australia, we use British system. And to convert them from one into another, basically you have to find the unit of fraction by looking at those tables. The given unit of measurement should appear in the denominator, so it will cancel up with the number that you want to convert. Let's look at some of these examples. I think this is the best way to do it. Sorry. Like, let's look at example 1, page 503. Okay, it says convert 14 inches to feet. You look at the table on the page 502, it tells you that 1 foot has 12 inches. So if you have 14 inches, you want to convert 14 inches to feet, okay? So you tell me, if I have 40 inches, I want to convert it to feet, by what should I multiply?
40 divided by 12.
What should be this unit of fraction? What goes up, what goes down?
You're on feet, right?
Yeah, you look at the table, it says 1 foot is 12 inches, okay? I want inch be down here, foot be up there. 1 foot is 12, okay? So that this inch will cancel out with that inch. Okay? So basically 14 divided by 12. That's the division is 3.3 keeps going on.
So you just do cancel out.
Yep. Whatever you want to convert, that original should go to the denominator so it cancels out. Let's look at, for example, example B. 13,200 feet to miles. We want to convert 13,200 feet. We want to find out how many miles is that. Is that right? So we have 13,200 feet. By what should I multiply? And remember, whatever you want to multiply, it should be down here to cancel out.
So it's 1 foot to bottom.
What should multiply?
And then it's going to be mile. You go miles.
Yes.
1 mile at the top.
Okay. No, but one feet is, you look at the table.
Well, one mile is feet, so we're doing it to miles. Right?
So, yeah.
My
would be-
mistake.
No. Look at that table.
5,280.
Feet is 1 mile. So 5 to 80. Yes, that makes sense. No.
Over 1 mile.
Oh, and this is feet.
Yes.
So we have, this should go, no. Yeah. 1 mile is 50 to 80. Okay? So the feet can cancel out. So we divide this by that number. You get 2.5. 2.5. All right. You following me? So, whatever you want to cancel, whatever you want to convert to from, if it's, you want to go from feet to mile, so you have to have the denominator should be that original. So these two will cancel. And the way you figure out, you look at the table, it says 1 mile is 50 to 80 feet. So 1 mile, 50 to 80. All right, let's look at example C in number 1. We have
Inches to yards.
I'm sorry?
9 inches to yards.
Yeah, we want to go from 9-inch. We want to find out how many 9 inches, how many yards. Okay, we look at the table. 1 yard is 36 inches. So this goes to the bottom, 30 inches. 1 yard. This is my unit of fraction. Multiplied by 9. 9 inches. Inches goes by inches. 9 divided by 9, 1. 9, 36 divided by 9 is 4. So it's 1/4 of yard. Or 0.5. Okay. So the key is to figuring out that unit of fraction. Example 5 of 6. Example 2, page 5 of 6. Here we want to convert between in a metric system. All right. We want to convert, for example, 504.7 meter to kilometer. Okay. 1 kilometer is how many meter? No, 1 kilometer is 1,000 meters. Look at that fraction. If you look at the table 9.2, 1 kilometer is 1,000 meters. So I want to convert, I have meter, I want to go to kilometer. What should be down here? Meter. What should be up here? Kilometer. 1 kilometer is 1,000 meters, right? Then you multiply 5.47 meter by that. Meter cancel by meter. You have 504.7 divided by 1,000, which is actually 1230. So I move the decimal. 1, 2, 3. 0.5447 kilometers. Almost half a kilometer. Example 506, let's do page 508. What happened? Oh, okay. All right. We want to convert 8 inches. Now we are moving from British to metric system. 8 inches. We want to find out 8 inches is how many centimeters. What do we do? When you look at table 9.3, table 9.3. Oh, yeah. 1 inches is 2.54 centimeters. So if I want to convert 8 inches, I have to multiply. What would be my unit of fraction? Inches goes down here, centimeter goes up there. 1, no. Let's see, 1 inches, yeah, we are right. I said 1 inches is 2.5.4 centimeters. So 8 inches we just multiply. Okay. Follow. Let's convert 125 miles to kilometer. 1 mile is 1.6 kilometers. So I want a unit of fraction that has mile here and kilometer up there. 1 mile is 1.6 kilometers. I multiply that. Mile goes by mile, 125 multiplied by 1.6. We have, now, the last one is really tricky. Converting 26,800 millimeter. We want to convert that to inches. How will we do that? Because table 9.3 doesn't have direct conversion from millimeter to inches. It has 1 inches to, it says 1 inch is 1 inch is 2.54 centimeters.
We would have to know how many millimeters and centimeters.
Okay. You know that? 1 meter is equal to 10 centimeter or equal to 1,000 millimeter. The word millimeter comes from that. You get the word millennium from there. So, if 10 centimeter is equal to 1,000 millimeter, 1 centimeter is equal to how many millimeters? And just divide both sides by 10. 100. Okay? So therefore, what we have, first we convert this 26,800 millimeter to centimeter. 1 centimeter is equal to 100 millimeter. In order to convert that, so I have 26,800 millimeter. 1 centimeter is equal to 100 millimeter. Millimeters cancel, this cancel, so you get 268. So 1 centimeter is equal to 268 millimeters. Follow? So basically, if you want, yeah, but, I'm sorry, it's pulling out what I meant. 26,800 divided by 100. So I'm not sure I did this correctly. So basically divided by 10, yeah. 1 centimeter. Yeah, I'm sorry. This I was going to put here is not right. 1 centimeter. Let me give you that. 1 meter is 10 centimeter. 1 meter is equal to 1,000 millimeter. Okay. So we will have 1 centimeter would be equal to 10, or it would be equal to 10 millimeters. Yeah. Yeah, you just divide it by 10. So 26,800, you divide it by 10, it becomes 2680 centimeters. Okay? Did you follow me? All right. And then we know 1 inches, 1 inch is 2.54 centimeters. So we multiply that by that fraction. 2.54 centimeters. These cancel. Basically, we have 2680 divided by 2.54. And the answer is about 1055 inches. So in this example, we have to first convert millimeter to centimeter to find out the value to make that conversion. We know 1 meter is, 1 meter is 100 centimeters. This is decimeter. And 1 meter is 1,000 millimeters, that was mixed. So 100 centimeters, you follow me here? 1 meter is 100 centimeters, yes? Okay. 1 meter is 1,000 millimeters, yes? So 1 centimeter is how many millimeters? Divided by 100, both sides, 10 millimeters. Okay? All right? 1 meter is equal to 10 decimeter. Okay? All right. Do you guys need a break?
Yeah.
Are you okay? We can continue?
Unless you want to break.
No, no, I'm okay. Let's go to example 4, page 509. Okay, the speed limit on many highways in the United States is 55. Well, that's clear. Okay. 55 miles per hour. How many kilometers per hour is this? We want to convert that to kilometer per hour. Look what it did. There's on table 9.3 tells us 1 mile is equal to 1.6 kilometers. So if I want to convert this 55 miles per hour to kilometer per hour, I have to multiply. What should be at the top? What should be the bottom? Okay, which is what? No, I have the 55.
Oh.
What should be, this is our unit of fraction.
Oh, 1 mile.
1 mile. Yes. And what should go up here?
It's like 1 mile.
1 mile cancels with mile. So you get 55 times 1.6 kilometer per hour. Which I think is about 75 or 88. 88 kilometers per hour. Which I heard in Europe is much, much faster. I heard in Europe, in Germany, I heard it's about 100 kilometers per hour, something like that. Some of their highways.
Yeah, but actually, let's try it again.
Yeah, we have a freeway.
Yeah.
It's even every installed.
It's called the other one.
Autobahns. Yeah.
Yeah.
Good Lord.
You're just free to go.
Okay, let's look at the example 4B. We want to change 200 kilometers per hour to miles per hour. No, this is the other way around. 200 kilometers per hour. We want to change that to miles per hour. So what should I do? You guys tell me. This is the unit of fraction. 1 mile is equal to 1.6 kilometers. So 200 times what should go up there, what should go down there?
1 mile.
Yes. And 1.6 kilometers per hour down here. These two cancels. So 200 divided by 1.6, which is 125 miles. Which actually I heard sometime in some of those autobahns they go by that speed. Just think of it as 125 miles per hour. Just think of driving like that in the United States.
You can't do it.
No, I don't want to do it.
I've been on the other one a few times.
It's crazy. Okay, we come to calculation of volumes and areas. Some of these formulas you just have to memorize. You know, area of a circle is pi times The diameter to power of 2, the half circle is half of that. Triangle, base times height divided by 2. Square is simple, rectangular, just width times height, and so on. So if you have different numbers, you just plug into the formula. For example, look at this picture in PowerPoint that I say calculate the area. If you want to calculate this area, what would you do?
You want to calculate the area?
Mm-hmm. The area within that boundary. So,
We'll take all your measurements.
yeah, 3 inches, 3 centimeter here. Okay, if 3 centimeter here, that means each of these is 3. That means this part is also, that top part is 3. So I have 3 times 7. Yeah, 20. 21 centimeters. I'm quite careful. People who are assuming. This is 3, this is 7. So this part, or we were drawing, should be 3, 2. So we get the area here is 21 centimeters squared. Right? Then here is 3 again. This is 6. If this is 3, what would be here?
2.
No. Is it 2?
Yeah, they'll all have like 1, 2, 3, 4, 5.
So wait a minute. If it's so if that's 2, actually, this shouldn't be 21. I thought this was 2. This should be 2. So we have 3 times. Well, it doesn't matter. No. This is 21 because you get this area 21 centimeters squared. Okay. So this is 2, this is 2. And this is 3, and this is 3. Yes?
Yes.
Okay, so 2 times 3, 6. 6 centimeters squared. So this is 21. That middle part, 6 centimeters squared. What would be here?
8.
All right, yes, 18. So we have 21 plus 6 plus 18, which would be 45. Yes? All right.
It's not very square.
Volume, if, basically you measure the base, multiply by the height. 5 centimeter times 3, or times the length, whatever. You need to have length, width, and the height to get the volume for a rectangular shape. Here you have a cube, you have rectangular prism, a cylinder, you have all these formula. 3-dimensional figures, you need to have those dimensions in order to 3 dimensions to measure the volume. All right? Basically, you got to memorize this. Changing units from one unit to another. Example 2, page 521. It says, if you have aquarium holds 0.25 meter cube, cubic of water. How much does the water weigh? You have the table up there, tells you 1 meter cubic weighs 1,000 kilograms. So you just take that number and multiply by 1,000, 450 kilograms. Okay? If you don't have, let me. You know, you have that table tells us 1 meter cubic is 1,000 kilogram weight or 1 ton. If our aquarium holds 0.25 meter cubic, how much its weight? We multiply it by 1,000 kilogram, because 1,000 kilogram is 1 meter cubic. These cancel 0.25 times 1,000, you get 250 kilograms. All right. If holds 0.145 meter cubic, again, how much the water holds weight, then you do the same thing. You 0.145 meter cubic by 100,000. Over 1 cubic. What would be the answer? This cancel with that.
1,000 times 0.
4.5. That's it. 145. Because this small. All right. If you want, same thing. Example 3, converts 160 pounds to kilogram. £160. You want to go to kilogram. Okay, what's my unit of fraction? 1 pound is how many kilograms?
0.4.
Right? So, where should I put that 1? Yeah, 1 pound. And the top is 0.45. So you have 160 times that is pound cancel, 160 times 0.45 kilogram. And you have to answer next page. 72. Okay. The second example, convert 300 grams to ounce. We use a unit fraction with ounce in numerator and gram in the denominator, and multiply by 300 grams, you get 10.7 ounce. All right. Then we come also to, let's see, temperature, Celsius and Fahrenheit. Basically, if you want to convert from Celsius to Fahrenheit, you have to use that formula. Okay, 9/5 times the degree in Celsius plus 32 Celsius. Example 4, page 523. The bills from your European vacation have you feeling a bit feverish, so you decide to take your temperature. The thermometer reads 37 centigrade. Should you panic? If it's 37 centigrade, as you can see, you plug it into that formula, 9/5 times 37 plus 32 is 98.6. No need to panic. Your temperature is 98.6. All right?
that 9/5, where does that come from again?
That's just part of the formula.
Oh, that's just the one.
Yeah, just part of the formula. Fahrenheit is equal 9/5 times whatever degree in centigrade plus 32. If you want to do the reverse from Fahrenheit to Celsius, this is the formula you use. 5/9 times the degree in Fahrenheit times the degree in Fahrenheit minus 32. Okay, because 32, you got to remember that 32 Fahrenheit is 0 centigrade. So on page 524, you have, it says the temperature on a warm spring day is 77 Fahrenheit. Convert that to Celsius. So you write the formula. Celsius is equal to 5/9 parentheses Fahrenheit minus 32, and you just plug in, instead of F, you put 77. You do the subtraction, as you can see in your textbook on page 524. And it's equal to 25 centigrade. Okay? That's it. And then just if you have any question about the midterm, basically, if you know, let me just mention a few things about the last quiz. Answer this question. A number is defined as a counting number with exactly 2 different factors. What is that number?
2 factors. Is it prime?
Prime. Yeah. Okay. What kind of number is a counting number with more than 2 different factors?
Let's start with C.
Composite. Yeah. Is 17 a prime or composite number? No, that's 17. It's prime because it can only be divided by itself and 1. All right. 28. Is it prime or composite? Can be divided by itself, by 1, by 2, by 14, by 7. 55, is it prime or composite? No, I'm sorry, 25.
Or composite.
Composite. Yeah. 2, is it prime or composite? Hmm? 2. Yeah.
Prime.
Yeah. Yep. 31, prime or composite? All right, let me check some. Okay, let me check these. How many? Oh, here. Okay. We have square root of 80 divided by square root of 5. How will you do that? Your vote is the same, so I can write 1 square root, okay? And I would have 80 divided by 5. What's 80 divided by 5? 16. Exactly. So 16. What's the square root of 16? 4. That's the answer. All right. Let's do, if I have 6.9 times 10 to the power of minus 8 divided 3 times 10 to the power of minus 2, what would be the answer? First, think of these.
So what you're gonna do is that will become a positive.
Is it because the negative 8 and negative 2 becomes
Okay, it becomes 10 to the power of minus 8 minus 2, which becomes 10 to the power of minus plus 2, 10 to the power of minus 6. And then you just have to do this division, which is 1.3. So, which if you look at this. Yeah. So I have 1, 2, 3, 4, 5. Yeah. So the final answer would be 0.5, 2, 4, 5, 7. Okay. Following. All right. Let's go to another one. If I have 0.1, 2, 3, 4, 5, 6, 7, 8, 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 92. If I want to write it in scientific notation, what do I do? Take this, bring it here. You want to put 9.2, you want to move the decimal here, times 10 to the power of. I am moving the decimal this way, so this should be power of negative 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You follow?
we got the negative because it was after the
Yeah, because it's after, it's on the right-hand side of the decimal point. So I want to move this decimal right over. I want to move this decimal, move it over here. Okay? So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 because these are on the right hand side. It's, if actually looking at it, it would be on the left hand side of a decimal point. It has to be negative. Right? 1 over 5 plus 7 over 8 what we gotta do? I have to make these the same.
Yeah, you have to.
So I multiply. Did you guys follow this part? Did you follow this?
Yeah, it just takes a little work on it. But you have to do cross multiplication or 5 times 3.
No, I know, but did you guys follow this one? Okay, are you guys okay? Yes, thanks. Okay. Now, this one, I want to make the denominator the same. I have to multiply the top and the bottom by that number, the top and bottom of this one by this number. Becomes 40, 8 over 40 plus 75 over 40. So I get 35 plus 8, 43 over 40. Okay? You can just leave it there, or if you want to get it out in the proper fraction, 40. But this is also one.
So, unless it tells us to go to the lowest, you don't have to.
No. But, you know, that number of people did a mistake on that to a square root. I'm surprised. You know, when you have the square root of 18 and the square root of 15, because these are the same, you can make it into 1, and it's just 80 divided by 15, which is 16, and get it out of the under the square root sign.
I mean, at first when you look at it, you.
Okay. Any question? Basically done.
How long, I mean, is it, midterm obviously is going to time. How long do we have to do it?
I gave you 2 hours. So you have, it's 45 questions, and I gave you 2 hours. Lots of them are just very short. You just have to answer one word, or they are not all of them multiplication, you know.
So no download answer.
No. Just go there and wait.
2 hours.
I'm sure you can do it much faster than that.
Friday night. That's what I'm doing.
Any question? Please watch the videos on each lesson. You know, those are for your own help and benefit.
It goes up to what we finished tonight, right?
Yeah. And again, remember, PowerPoints are all, I postponed all of them to the last session. Session 7. Okay.
Yes.
So I guess if no question, we are done. So I'm going to stop this. Let me pray and dismiss you. Again, Father, we thank you for this time, and I pray that your blessing be upon all these dear students in this course and any other classes that you are taking. Bless them, strengthen them, take care of them in their work, ministry, family. In Jesus' name we pray. Amen. You are welcome. Okay.